Hello and welcome back to Connor's Chemistry. I'm doing lots of videos at the moment on these questions as my year 11 class keep going on at me to add some more videos and to give them a bit of a shout out. So hello class and well done on your physics results today. Super impressed, you are absolute superstars. Anyway, back to this question. This question then is question 6 from the specimen paper and talks about exothermic reactions. Okay, and as soon as you see that exothermic, we are thinking a reaction that has some energy left over. So it's kind of combustion and it will be heating up the surroundings. Okay, so this one's right, heating the surroundings. Okay, and it says that there. So we've told us that word, they love that word in the GCSE. And it says, draw a reaction profile. And there are two versions of this, and we have to draw the exothermic one using the axes in figure 5. It's only worth 2 marks, so it should be something you should be able to recreate quite quickly. Show the relative energies of the reactants and products. So this is what's going in, this is then what's coming out, what produced at the end of our reaction. The activation energy and the overall energy change in terms of what's changed. Now I would expect this to happen and you have to draw this quite quickly. Again, just like with the radius of the atom, this is something you kind of just need to be able to remember and apply and draw in your exam. So because it's exothermic, we know the reactants is going to be much higher than our products. Okay, and to make sure we know that, we're going to just write reactants here and products here. Okay, because it's an exothermic reaction, we're going to have some energy left over. So combustion, for example, feels warm because it's given that, transferring that energy into our surroundings. We always have a little lump at the top that will then join up with our products. So you know that little line. And this line, when we draw a little dotted line here, this here is our activation energy. This is the energy needed to actually make the reaction start, so to activate the reaction. Okay, we can also put a little line here if we want to, just to show that it's this amount of energy. We could also draw a little arrow if we wanted to, so we're very clear. We also then need to look at what we had to do. We've done the energies of the reactants and products, we've labelled the activation energy, it's now the overall energy change. So actually that's really easy because this is the overall energy change, so I can draw my little dotted line here as well. And this part of our little reaction profile diagram is the overall energy change. That's how much the energy has changed. But we had to have some energy, our activation energy, to be able to get the reaction to start. Now this is what an exothermic reaction, and an endothermic reaction is the opposite. So we start lower and then our products are higher because they need to take in energy from our surroundings.